My name is Manish, and I'm going to talk about assessing the quality of AI-generated code. While AI is helping us produce a lot of code, it's helping us become more productive. We do need to be careful about the quality of the code and what it is producing and things like that. So I'm based in Austin, and I lead the product and solutions team at Sonar. So let's get started. Do we have a pointer? Clicker? No? Okay. All right. We'll do it the old school way. I'll use the keypad here. So AI, this is nothing new to you, right? AI is writing a huge amount of code. The volume of code that is being created, you can see by the red line, it's like amazingly high. While the code being produced is exponentially growing, the gap between the code that developers used to write and what AI is writing, that gap is growing. But is that code good? Are you checking the quality of that code? Are you confident that the code that AI is producing can be deployed in production? So that's a topic we'll look at today. At Sonar, we are all about helping developers and AI produce better code. And by better code, I mean code that is reliable, sustainable, maintainable, readable, modular. We look at all attributes of the code and look at code as provide you a code health dashboard and view and things that you can improve with your code. So we have a set of products, but I'll not talk about products too much here. I'll talk about what are the things which you should watch out for when you are using AI coding. I've been in the industry for more than 20 years, and this stat from Stack Overflow, only 3% of developers highly trust the accuracy of AI code. I've never seen this low an adoption and trust factor in any technology in last 20 years, whether it was Java, whether it was microservices, whether it's cloud native, whether it's DevOps. The trust that the code is highly reliable, is production ready, is very, very less. And why is that? Because LLMs by nature are probabilistic. They can hallucinate. They can produce code which is functional, but may not be efficient, may not be reliable, may be complex, may be too verbose. It can contain security issues. Because of several factors, you have to basically be careful about what the code is being produced looks like. So one of the things that is what we are seeing, and this is we have over 400,000 customers using our products, and the constant feedback that we're getting is that speed of writing code is no longer a bottleneck. What has become a bottleneck is after you've written the code. The processes in SDLC after you've written the code. How do you verify that volume of code at a speed at which it is producing without compromising on the code quality and security, right? So the gap between the blue line and red line shows the gap in terms of verification, how quickly you can verify your code that is being generated, right? So how many of you trust AI written code? Can I get a raise of hands? Okay, I thought so. So we have some vibe coders and some folks who use AI for prototyping and things like that for smaller use cases, and it makes sense, you can trust that code. But if you are writing any mission critical applications or production applications or healthcare applications or financial applications, you better make sure that the code that is being written or produced by AI is good quality, it's ready to be used in production, right? So what the LLM industry is, whether it's OpenAI, whether it's XAI, whether it's Claude, whether it's Gemini, look at every state-of-the-art model. How do they evaluate the models? They have benchmarks, right? And the benchmarks for coding are things like human eval, MBPP. These are the benchmarks that industry uses to evaluate models. The higher you score in a benchmark, the model provider says, I can almost solve 80% of the coding problems, right? That's not the whole story. Benchmarks are important. They do have a place, but they should not be the only signal to let you know that the code is good, right? So benchmarks are basically, if you look at human eval benchmarks, it's basically asking LLMs to write some algorithms for you. is checking whether they're functionally correct or not. The code which they are producing is functionally correct or not. Whether it's passing or failing certain specific tasks or not. That's the kind of evaluation they're doing with the benchmarks. What is missing in the benchmarks is the qualitative analysis, the security of that code. They don't evaluate whether the code being produced by GPT-5 or GPT 5.1 or Claude 3.7 or Claude 4.x is secure or not. They don't measure whether the code has any maintainability issues. They don't look at the quality of the code at all. And for us at Sonar, our whole mission for last 17 years, and by the way, it is a coincidence, we are celebrating 17th anniversary today of Sonar. So happy to be here celebrating the 17th anniversary of our company today. So for us, it's all about empowering the developers, empowering AI agents, AI tools to produce better code. Code that you can trust and rely on, right? So we at Sonar, we did a deep analysis of all the 6 LLMs listed on the slide here, GPT-5 with the minimal reasoning, GPT-4, Claude 4, Claude Sonnet 3.7, MetaLlama, and OpenCoder 8B. So if you look at these models that we evaluated, we took the whole spectrum to represent the kind of full spectrum. We started with OpenCoder, which is an open source based, relatively small language model. And we looked at the biggest and the latest iteration of GPT-5, which is a large language model, very high, with lots of reasoning modes. It has 4 reasoning modes. So it's the state-of-the-art model, right? So we looked at a small model. We looked at MetaLlama, which is an open source model. And we looked at commercial models from Claude and GPT, right? And we created a framework to analyze these models to go beyond the benchmarks. So the framework, what it does is basically we asked all these LLMs to solve 4,400 Java programming tasks, distinct tasks that they were not trained on, that they don't know about, they're not part of the benchmarks, right? These are net new tasks which we asked them to solve. And then using our product SonarQube Enterprise, we evaluated the code and found out what the results were. And that's what I'm going to share with you. So it helps you kind of, get an idea as to what kind of issues come up in the model and what you need to watch out for. So the results of this study are published on our website. You can scan the QR code to get the full result. Today in this talk, I'll just take about 30 minutes to cover everything here, in a short form, in a summary of what we found. But you can always look at the full report on our website. What we found was all models produce a large number of coding issues. And what are the coding issues? I'll talk about it in the upcoming slides. Bigger and newer models is not always better. Some tasks can be done equally good with a small open source model or a small language model. So you don't need to get a high reasoning model to do certain tasks. Changing reasoning levels does get you better quality of code for the most part, but it does come with some compromises. And I'll tell you what those compromises you make when you pay for a higher reasoning model. And each model has kind of a unique personality, and that personality trait is described in the PDF report, but we'll not talk about the personalities today. And why are the LLMs having these challenges? These challenges broadly are in 3 areas, right? One is the quality of data they are trained on. They are trained on the same data that we as developers wrote, the code that we wrote for the last 20 years. They are inheriting the same security bugs that were there in our code for the last 20 years. They have hidden bugs and logic errors, and they are probabilistic in nature. Yeah, that's the next slide. So they are probabilistic in nature. They have limited context, and they are not explainable. This is just the nature of LLMs. While they will help you write code faster, they are still probabilistic. They will work based on pattern matching. They will produce wrong patterns. If you ask an LLM to write the same code 3 times, chances are you will get different results 3 times. It will sometimes be more verbose, sometimes it might be buggy, sometimes it might be complex. So you will find variability in terms of the code being produced. And they have limited context, and whatever they produce, they cannot be explained. How many of you have tried ChatGPT or Gemini or any of the chat interfaces with LLM where you say, hey, 2 plus 2 is 5. And the LLM says, yeah, you're right. I got it wrong, right? So they are inevitably trained to say, you are always right, and they will always try to answer a question for you. Similarly, for coding, they will always produce a code. And if you challenge a rightly written code and tell them, hey, this code is wrong, I can bet you that quite a few times they will say, okay, yes, you're right, I made a mistake here. And they will, try to fix it when there was no mistake there. Or they will produce wrong results. So every model has its own personality, we talked about it. And the big takeaway from this slide is, you remember the first slide where I talked about large volume of code? As a developer, I was writing, if I write a code, let me go back a little bit. So as a developer, if I'm writing a simple application, calculating my BMI, or converting Fahrenheit to centigrade, or some simple hello world kind of program, very basic program, right? I can write that code in 10 lines or 5 lines very easily. If I ask the LLMs to write that code, and if you ask the higher reasoning models to write that code, and this is just a basic example. If you take a real world example, you'll really see what I'm trying to say. If you ask the LLM to write a banking application, a microservices application, and you write that banking application, you will probably take less number of lines of code than the highest reasoning GPT-5 model. It'll produce a lot more complex code. It'll produce a lot more volume of code. And if there are issues in it, it's like finding a needle in a haystack. So you have to think about all those things when you start using LLMs more and more for your production applications. This is one of the slides. Now, in the next few slides, I'll talk about the findings from a research study that we did, the report that we published. So let me take a minute to explain this diagram here, this chart here. It's basically on the y-axis, you have cognitive complexity of a model, the code produced by a model. On the x-axis, you have the functional performance, which is typically the benchmark performance, right? How do they do on a benchmark, and how complex is the code being produced? Cognitive complexity, does anyone know what is cognitive complexity? Cognitive complexity is the ability for us to understand that code. Our human reasoning capabilities to understand and read that code is measured in a term called cognitive complexity, and we measure it and tell you for every code that you write, if it's too high, it's going to be very difficult to maintain. It's going to be very difficult to find issues in it. It'll have hidden security bugs which are very, very hard to detect, which a human developer cannot figure out, right? So cognitive complexity of Llama and OpenCoder was very less. But at the same time, the functional performance was also very, very less. But as you go to GPT-5 or Claude Sonnet 4, you see that the cognitive complexity of GPT-5, even with the minimal reasoning mode, is at 75% and 77% for Claude Sonnet 4. What does this tell you? It's saying it's producing code which is needlessly complex. It doesn't have to be that complex to solve that problem. So you need to be aware of the traits and personalities of each of these models, the reasoning modes that they have, and then decide for your use case which model makes sense. Looking at some more data, if you see, this is exactly what I was talking about earlier. So if you see this blue chart here, it says solve a programming task for me, and we gave that programming task to all the models. GPT-4 took 20,000 lines of code to solve it. Actually, it's 200,000. 200,000 lines of code to solve that programming task. GPT high reasoning mode took almost 75,000, 80,000 lines of code. It is the same task being solved by 6 different LLMs, and you can see the complexity of the code, how it's increasing. What does that lead to? It leads to higher cognitive complexity. It leads to higher cyclomatic complexity. Cyclomatic complexity is basically your function calling how many paths is it taking? How many times is it unnecessarily making calls, and the path that it's taking to achieve the result. That's a measure of, that's what cyclomatic complexity is. The higher the cyclomatic complexity, the higher the cognitive complexity, the more difficult the code becomes to maintain, the more chances are that there are hidden bugs that you cannot catch very easily. There are hidden security issues that you cannot catch easily. So we also looked at code smells. Code smells, as the name says, it's a term that we use within SonarQube Enterprise. If you're using SonarQube, you'll probably be familiar with it. But those who don't use it, it's about maintainability of the code. It measures whether the code is smelling bad or not, whether it looks bad or not, right? It's a So I'll tell you, if you have a if then, or a long loop or long set of things in a function, it's needlessly complex. It'll create codes. It's going to be a nightmare for the people who are going to manage that code eventually. Today, the AI will write it. 5 years later, somebody has to read it, maintain it. It's going to be very, very hard for them. So if you look at, this chart is even more interesting. So if you look at bugs, generally the bugs have been increasing as we grow from GPT-5 to GPT-5 high, GPT-4 to GPT-5 high. If you can see the blue line, it's number of bugs being produced by LLM is increasing. And if you look at the report, we'll tell you what kind of bugs it is producing. We have details of whether it's a part reversal bug, whether it's a buffer overflow bug, whether it's a secrets being leaked in terms of security bugs. We have details of what they are producing so you get a sense of it. If you look at total vulnerabilities, it is decreasing. So most of these LLM vendors, whether it's Claude, GPT, Gemini, they are getting better in terms of functional correctness. They are producing more complex code. Their security posture is getting better, but they are getting compromised with larger number of bugs, which are hard to find. They're compromised with code smells and things like that. So looking forward, what do we need to do, right? AI will write all code. That is obvious. That's a given. That's why we are all here. We know it's writing it already, and it's continuing to do it. It will produce verbose code. It will produce complex code. It will be used in enterprise applications. Guess what if something goes down? We had a keynote in the morning about governance and trust and things like that. We don't have too much of a governance here, which is a good and a bad thing, right? I mean, you want governance, but it should not be reducing your efficiency. It should not be holding you back. But that's where we come into play, Sonar. So how can you build responsible code that you can trust? So we have a solution that helps you verify and put some guardrails for the code that AI is generating or for the code that developers are creating. And we have been doing this for 16 years, and we have been adding more features and capabilities to detect issues that are unique to LLM-generated code. How many of you have heard about prompt injection attacks with LLMs? Quite a few, right? If you look at how you can detect those, there are hardly any companies who can do that. You have to write rules to detect those. LLMs cannot detect their own prompt injection attacks, for example. So we provide an independent, standardized verification layer for all your code. We've checked your code for improving the code quality, code security, and code maintainability so that you can trust the code that is being produced and used in your applications. We can detect over 7,000 types of issues, help you reduce technical debt, improve your developer productivity, and trust the code that is being generated. So how do we do that? This is the only marketing slide I have on my deck. I didn't talk too much about my company or my products. But for those of you who are not available, can I get a raise of hands? How many of you know SonarQube or use SonarQube? Oh, wow. Then I probably don't need to cover the slide, or maybe I do. There's about 30% of you or 25% who don't use SonarQube. So SonarQube is a platform for us which has several components to it. We have a cloud version and a server version. We have an ID extension, and we have an MCP server, which we launched recently. And we are coming out with a remediation agent next month. It's already in beta. So we help you write code starting from your ID. As soon as you write the first line of code, you can start checking it with our ID extension. And you can connect that ID extension to SonarQube Cloud and Server. And you can basically evaluate every pull request and their full branches, whether it's the main branch or your test branch. You can scan it and detect all the kinds of issues that I was talking about. We support 35 languages. We pretty much integrate with every DevOps platform, whether it's GitHub, GitLab, Bitbucket, any CI pipeline. And we are available for all the IDs, including Cursor, Windsurf, and AI native IDs, Visual Studio Code, all of those IDs. So it's basically sitting right in your SDLC along with where you are working, helps agents produce better code, helps developers produce better code, checks the code early in the ID, as well as in your pull request, as well as in your branch analysis. I'm very excited to take this opportunity to announce a product that we are working on. How many of you are building LLMs here? Okay. Okay, I see here, about 10, 12 people who are building models. So this slide is particularly relevant for model builders, whether you're building a state-of-the-art model or an open source model or your own fine-tuned model or custom models. We announced a product called SonarQube. It basically, there's an Anthropic paper which was published which said even a small amount of bad code can pollute the LLM training data. So this particular product, what it does, we're taking it even, shifting it even further left. Rather than starting in the ID, we are trying to help OpenAI, GPT-5, OpenAI, Gemini, and all these LLM providers get their models to train on data that is high quality. So we sweep the training coding data set with this service, and we basically ensure that the data that is being fed to the models is high quality. And what we have seen is from 50 to 65% reduction in security vulnerabilities in our tests, in our evaluation, just by improving the coding data set that is being used by models. So it's the same adage that goes garbage in, garbage out. So we are trying to clean out all the garbage and sweep out all the bad code from the training data set and help it make better. So I'll end my talk with some key takeaways. Benchmarks are needed, but they are not the only thing. Newer and more capable models are not always perfect. They are getting better with security, but they are introducing new challenges, which we typically don't get aware of unless we evaluate them properly. So evaluate your models. Verification is mandatory in this day and age. Code quality and security are non-negotiable. If you would like to learn more about our products and solutions, sonar.com is our website. And thank you for taking the time. And I hope you found this useful. Happy to take a couple of questions.
I see there are a lot of questions. Okay, let's start from here.
Yeah, I have a question. So in our company, we do a lot of mobile apps, mobile development, and there's this OWASP standard for mobile apps.
Yes.
And is that built in
yes.
into your checks?
Yes, we have OWASP top 10 for mobile as well as for non-mobile code. And we are also we are working on OWASP top 10 for LLMs. So we are building rules for detecting prompt injection attack, rules backdoor file attack, which are specific to LLMs. So OWASP top 10 for LLMs is for LLMs. So we do it for regular code, mobile, as well as going into LLMs.
And is it like built in as a plugin? So
it is built into SonarQube cloud and server in the enterprise plans. You get a report as how you're performing against those OWASP top 10 standards.
And will it dynamically correct the code?
Yes, so it'll tell you what the issue is, and we'll also have a remediation solution. We have an agent coming out. We have an AI code fix, which tells you this line of code is a problem. This is why it is a problem. This is how you fix it. And do you want to generate a fix? Yeah, thank you.
Yeah. By the way, really good presentation.
Thank you.
Thank you. I have a question because I think we already solved that problem about analyzing the code, checking vulnerabilities, checking smells, and all of that, right? But I think now the fear is because we are letting these agents to generate new code, generate even new business logic. Does Sonar provide some capability that will help to assess that new code that is being generated by an agent and really ensure that it's meeting all the requirements or something like that?
Yeah, so something related to that. So we are working on a capability called architecture observability. What it will do is it will look at your code base and visualize the architecture for you. And you can say, this is my good architecture. And how it drifts and becomes good to bad, we will evaluate it as part of your, as you develop code and tell you how the architecture is drifting. That may help you a little bit.
Hi, thanks for the presentation. Could you talk about Sonar's approach to doing security evaluations?
Can I talk about, sorry?
Sonar's approach to security evaluations, so looking for flaws, any vulnerabilities, yep.
Yeah, thanks. So I didn't get into the product specific features, but we do secrets detection, so we can detect leaked secrets starting from your ID to your pull request and in your full branch. We do SAST analysis, which is basically easy security bugs which you can find. We do taint analysis, which finds cross-site scripting issues and things like that.
And do you use AI to
No.
use, okay.
No, we don't use AI for any of our analysis. And the reason being, at Sonar, we believe that if LLM is writing the code, LLM should not be reviewing the code. While you can get LLMs to review the code, they are probabilistic by nature. They can make mistakes and they may not have the consistent results. For us, it's important to give consistent, predictable, deterministic results. So we use static code analysis for our thing. We also do SCA analysis, which is dependencies and SBOM and open source license management. And we also do advanced SAST, which is something unique to us, which is looking at your flow of your code into open source libraries and detecting issues.
Hi, Manish. Hi. Great talk, Manish. Thanks for that.
Yeah.
Agree with most of what you said. Just wanted to understand the part on the cognitive complexity.
Yeah.
If you're saying that LLMs, whatever code they generate, it's complex from a cognitive perspective. But why would you be worried about it? Because LLMs can understand and explain and probably even debug some of that code as well. So why do you measure that? That's the question.
Excellent question. So like I said, they are probabilistic, right? If you ask LLM to explain the same code 3 times, I can bet once it will give you a different answer. And if you argue with it and tell them that, you have explained it incorrectly, they're not explainable at all. So if you want assurance, if you want guardrails, if you want deterministic results, if you want predictable results, if you want consistent results, you would not get it from LLMs. It's the nature of the LLMs, right? So that's why we believe in having probabilistic approach for writing codes, but a deterministic guardrail to make sure it's doing it right.